my calculus courses, I lectured the entire 2 hours for calculus 2 course. It wasn't recording. So I'm saying is it's being real weird. Input. Thank you. Okay. Integers. What are they? Yes. From negative infinity and then to positive infinity. All the numbers, not decimals. So no decimals. So now what we're going to do here first, we're going to look at multiplication in what the kids already know. Because what do the kids know so far? What operations of math do they know? No, they don't. This is what they're trying to teach them this. Yeah. They know addition and they know subtraction. Which is great because we'll need both of those to define multiplication and division. Basically, that's the way you could define multiplication. Multiplication is turbo addition. Repeated addition. So if I have the same number and I repeat it, that's pretty boring. And then you have to count. You said, okay, I have 3 plus 3 is 6 plus 3 is 9. Or we could do a shortcut since it's this number repeated how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We know it's going to equal 33. So now, how does it equal? That's the tough part. How do we know it's going to equal 33? Because the kids just learned addition and subtraction. Now we're going to say, okay, well, what's this all about? How do I get 33? Well, you could try to say, okay, we have the 11. There's the multiplication symbol. 3 times 3 is 3. 3 times 1.
Whenever we are choosing that method, is sometimes like our normally with my class, sometimes like kids will sometimes like not know what way to go. Like we don't know how we go first we do our number above and then we go to our next number.
Yes. How do you help them with that?
I would say kind of like draw, like to keep them
The circles?
Yeah. To keep them kind of like to follow in order.
Okay, yeah. Because the first one goes in the first one, the second one goes in the second one, third one. But now they might ask, why is it like that? Because remember, we have to look at what is 11 made up of? 10 plus 1. And if we multiply it by 3, so we have 10 threes. That's, we have to go back down to that. But 3 times 1, it means you only have 1 3. But yeah, that's one of the hardest things is how do you know? Because then you jump up to 2-digit numbers. that's even more difficult because this first one gets these first numbers. The second one, I have to move over one, put a 0 there. That's where it gets more complicated. I mean, that's why I had trouble with this.
Or I need to knock up a 0 and I don't mess up my whole addition at the bottom.
I did that when I was in elementary school. I had the right numbers, but in the wrong order. So, but yeah, that's why it's very important to tell them that you have to know what each of these numbers. That's the ones, that's the tens, and again, you could use the blocks. Manipulatives are fabulous for kids. Actually, they're great for adults too. And that's a hopefully we'll finish with enough time that we can spend the rest of the semester just doing nothing but manipulatives. I want to do it now. I want to do it so bad with manipulatives in this class. It's that if I do that, then will I have enough time? Because I barely finish a whole lecture just of me talking. But yes, that's why I want to finish up as fast as I can. And we're in good shape actually. Because if you look at our calendar, we're right here right now. These two will go together. That one. Operations and terminating decimals, all of these three together we could do. This is 1 week, this is another week. This is another week. Actually, this is another day. And then we could do, so we'll finish in about 3-4 weeks, which will give us 3 weeks to do nothing but manipulatives and review or sleep in later. So now, if you use manipulatives, grouping, how would you do grouping? How would you show, let's say, 3 times 5? Yeah. Okay. Rule 1: you would never jump 2-digit numbers until they understand this. But yeah, that's if we did that, they'd blow their mind. So they wouldn't know what to do. So how would you do this? Remember, the kids also learned the properties, hopefully, the commutative property, which also means the same as this. We could say that this, we have 3 sets. Inside each set, we have 5 dots. Now we add 5 plus 5 plus 5. So, and the incentives that, so we could do this method multiplication. We know we could jump straight to that instead of once you understand what's going on there. Or we can have 5 sets, and inside each one, I have 3. So it's 3 plus 3. Why would you show it to them this way? Oh, it's 6. Yeah.
That's not the same number. Maybe they're flipped, they'll still be the same amount, or their sum will still be the same.
Yeah, and that show them commutativity. But why would you show it to them? I mean, what would be your catchphrase for it? Do they like to draw a bunch of circles with dots in it, or which is less writing? This adding 5 3 times, or adding 3 5 times? Yeah, it's you like this one. That's too much writing. Because if you the more writing, the rule of thumb is that the more you write, the more chance you'll make a mistake.
But we also have kids, they're not gonna want to do the whole thing.
Exactly. So yeah, so well, because of commutativity, instead of writing it this way, which is hurt your hand, we can do it smaller, faster. And then kids, they'll learn twos, adding twos, 2, 4, 6, 8, then they'll learn 5, 10, 15, 20. 3s and 7s and 8s are going to be the most difficult ones. And well, 9s, you can use your fingers. But yeah, when it comes to that, you go with the numbers that are easier for them to learn. Okay, how would we use a number line? Yes. We start here. We're going to start at 0 here.
Well, I guess it would be like, it would be like 2 times 2, then we'll move over to, and then plus 0, so we're gonna add another 2.
Yes, exactly. Yes. So let's say we did 2 times 3. So we start at 0. You go over 2 spaces. You do that 3 times. So here's the first one. Here's the second one. And then we also refresh. So if we start at 3, we go over 3 spaces. 1, 2, 3. 1, 2, 3. And we get the same. So as long as we have the numbers in any order, we could do the same, get the same answer. So we have any examples here. Oh, because remember, we're dealing with integers. Positive, move right. Negative, move left. So that's so we had 2 times -3.
Right, 2, and then back to 3.
But then when we get 1, that's subtraction. There are a couple ways. Oops, this is supposed to be multiplication. It's 2 times -3. What we can remember, we can say that the first number tells us how many spaces we jump. And we jump this many spaces. So this one says we jump 2 sets of 3, but they're going in the left direction. 1, 2, 3. 1, 2, 3. And since we're to the left of 0, it equals -6. Now, commutativity is going to be difficult to prove to them with negative numbers. What you have to remember, you teach them, is if you move a number, that sign stays with the number. And hopefully that is impressed upon them when we talk about addition and subtraction. Because remember, 3 minus 4 is not the same as 4 minus 3. It's the same as 3 plus -4. So that means I can move them around. -4 plus 3. So we do the same thing with multiplication. Or there's another way we can teach them. In multiplication, if one number is negative, now we'll come to the properties. If one number is negative, the whole thing's negative. So we could take out the negative and have 3 times 2. So make it -6. Which is how we'd show this. But what about something like this? How would you show that to the kids?
Negative signs, they don't go together, so that they cancel each other out, or that they don't want to be together. So
Well, see, yeah, that's the way we were taught. But because of inclusion and everything else, can you say they can't be together because they don't? Then it's oh, mommy, no, 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 and you get in trouble with the school saying, yeah, we can't we can't teach them the way we used to. We were taught. We turned out okay, but our kids nowadays, no.
Have like a circle chart where it's like, for like our positive, negative, and like, or like, kind of like a guide, where it's like, well, we have like positive, negative, it'll be negative. If you have a negative and a negative, it'll turn to positive.
But yeah, you didn't have to explain it to them because they may not like charts. But no, I do like what you said about it is like a switch. Remember, you have zeros here, positive is on this side, negative is on that side. Also, you show them that negative is opposite. So if we have a number two is on the right side of the zero. But -2 is two spaces, but on the other side. They're the same distance apart away from zero. But this one says go to the left. In other words, they're used to going this way. After all the trials and everything, now we put a negative, so that means we switch. We have to switch directions. Which means is now this thing says I switched instead of going this way, I gotta go this way, two spaces. Which is where the double negative comes in. The first one says, okay, normally I go this way, but that negative says I have to switch, I have to go this way. But this one switches it again. So the first one says go left. Then the second one says switch using the concept of opposites. So go to the right, now we'll go to the left, and or left and to the right. I'm not gonna lie to you, negatives are the number one problem that people have in math, even as adults. If you look at an algebra test, that little sign will cause more mistakes than anything else. Because we've never had a solid foundation of what negative really means. So for your project, you can find some fun activities to teach negatives. Like having the kids stand on a number line, and if you give them this first number says walk backwards. So from where they are, they take 3 steps backwards. Now they take 5 steps forward. What number do they land on? Yeah. So this one from here, we go down to -3. And then when we add 5, we go to +2. Yeah, it's not going to be much difficult doing this. Simply because now negative means take away. That's not going to be any problem at all. You have 5 apples, you take away 3. How many do you have left? You have 2. The problem comes when you move the negative in front. Or if they're both negative, you may have equations like this. And this is where the taking apples out of a container gets difficult. Because if you start off with you have a container, you take away 3 apples. Well, how many did you start off with? I had nothing. You have empty. You start off. Nah, I owe you 3 apples, and I owe you 3 more. So that's going to be a complicated concept for them to understand. So that's why using number lines it'll help you a lot. Saying okay, always start at 0. The first number says go to the left 3 and then to the right. But now, how does that relate to multiplication? 2 times -3. We have 2 sets of red You can use chips. Red chips means negative, blue or white chips mean positive. So we have two sets of 3 red chips. So now you have 6 red chips, which makes it -6. And that's going to be the difficult part there, is figure out what's the best thing for my kids.
I feel like you also, as a teacher, you could also base off like how they understand addition, how they understand their subtraction. And like from there, you can kind of see how you introduce multiplication to them.
Yes. Yeah, and that's why addition is very addition. Once you understand addition, then you can start talking about subtraction, which again, we talked about this a couple weeks back. We teach them that way in mathematics, but in the rest of the class, when we sing songs in class, it's the monkeys jump off the bed. It's always subtraction. So that's what my wife is starting off. Start off with teaching subtraction, because you had 5, you take away 1, you have how many now? 5 monkeys jumping on the bed. 1 fell off, so you have 4. You take away 1 more, you have 3. Because that's the way that they can sing it to their head. So because now this thing on the number line, it goes backwards. We have 5 numbers. Here's 0. We have 5 monkeys. Lose 1, lose 1, and keep on with that one.
But now, are kids learning addition subtraction in first grade, or would that be kindergarten?
Kindergarten, because they're learning numbers already in pre-K.
I went to the volunteer for, and I went to kindergarten class, and it's just telling me that right now, they're learning about shapes, and then they just
Right.
recently went over numbers. And I do remember I asked her, I'm like, oh, is addition or subtraction like in the agenda right now? And she was saying that she'll want to get that far, but right now, the kids are still struggling like in their shapes.
But now that's kind of backwards. You have to teach them numbers first, because how are you going to define a shape? That's a triangle. How do you know it's a triangle? It's got 3 sides. Well, what's 3? So you have to do numbers first, and then for numbers, you could now you start off with a triangle, 3 sides. Okay, now everybody knows what that is. That's a square. It has 1, 2, so it's 1, 2, 3. So it's bigger than a triangle. How many sides does it have? And that's where you help kids. That's if they know the numbers, then they can just learn. And this helps in their counting. And actually, I think the shapes and numbers are backwards. They should be numbers first.
There are a lot of kids who do know their numbers. It's just also a lot of kids who struggle to remember the names of the number, or those like they'll mix them up.
Oh, yes. Yeah, because that's our entire language is symbolic. Any language. I mean, if I'm learning Spanish, and I know French, I know Polish, I know German, I know a little bit of Latin, a little bit of Arabic. So I get mixed up with the words sometimes. I mean, I can speak to my relatives in French. I'm throwing some Polish words because that's how we grew up. But if I go to Paris, or if anywhere in France and start speaking, I get what? So yeah, we have to remember what those words mean in that language, and that's very true. That's the part that you'll have trouble with, is because it takes practice. You can't learn it without practicing it. And do the kids practice at home? No, they go home, mommy gives them a little iPad to play with, and they watch TV all day. And yeah, you learn how to hate that. All right. Well, so we could use this to show them a pattern. So if we start at 10, we have 10 objects. This thing says we take away 2. So now we have 8 objects. Take away 2 more. So we look at it. If we subtract by 2, then subtract by 3, subtract by 5, and see how that works. And once the kids notice a pattern, eventually what happens is 6 goes down to 4, 4 goes down to 2, 2 goes down to 0. Do we stop there? No, because we're dealing with integers. So we started off at 10. We went to 8. We went to 6. We went to 4. Went to 2. 0. Now what do you have? Well, since you're to the left of 0. And what is this going to make the kids notice? But yeah, but there's another thing. Because when we first learn the number line, we teach them greater than. 6 is greater than 4. Why is 6 greater than 4? Well, because it's to the right of 4. It's greater value because it's further to the right. So any number to the right of another number is greater. So that's how you make them relate smaller to bigger numbers. The size is depending on where they are on the number line. How far are they from 0? But look what happens on the negative side. Yes, the bigger the number, a negative, the smaller it is. So negative 10 is less than 0. But 0 is less than 10. So yeah, this is another concept that you'll have trouble showing them. But again, that's the tough part about integers is even adults. A lot of times in class when I put up in my algebra class, if I put up two numbers, I put negative 10 and negative 4. Which one's bigger? Well, a lot of times they'll say that. Not because 10 is bigger than 4. No, but 10 is negative. It's further to the left. No.
Yes.
I did the same thing. So we have to define what multiplication is all about with signed numbers. The concept of multiplication is pretty easy. It's addition. But once we introduce signs, we have three rules for multiplication of signed numbers. The first one, we have A and B. A and B are both greater than or equal to 0. So what we're doing here is if A and B are both positive, it means they're both positive. That's another concept you have to remember. You have to tell them, okay, if I'm saying positive, what does that mean? It's greater than 0. It's less than 0. Because again, all these are based on words. You have to understand what greater than less than means. Because again, when you're instructing things, saying A and B are greater than 0, that means they're positive. And if I multiply them together, that product will be greater than or equal to 0. 3 times 2, positive 6. Okay. A and B are both less than or equal to 0. Means they're both negative. The tough part about this is a lot of math books you'll see is introducing absolute value signs. Because what this really means is since they're both negative, then I take the absolute value of them, and that gets rid of the negative signs. Now, I like what you said earlier, but not like you said earlier is they don't like each other, so they're alone. To make a negative, It only takes one line. If you have two lines, you can make a positive. So if I have a -2 and a -3, I can take both of those together and make a positive 2 times 3. Surprisingly, that sticks with kids a little bit better. Because even when you have those manipulators, you stick them on your board, you can now take them and put them on top of each other and say that's a plus sign now. And then the last one, if A is positive and B is negative, then what we get here is so if we had -A times +B, since there's only one, I could take that negative sign out. And that's what I have. Again, and which rule do we say this? Because we introduced distributivity earlier. AX plus AY. Distributivity goes this way. What we're doing here is we're factoring pretty much. What do they both have in common? We can factor something out. They both have an A. And if I take out the A, all I have left is X plus Y. This is what I'm doing here. I'm taking the signs. I'm taking them out. So there's that signs. This is a negative. This is nothing. And then A and B. And yeah, then you'll have some kids saying, because they're mommy and daddy might help them. And they'll say, yeah, if you have opposites, then they'll say, if you have the same signs and you multiply them, that equals plus. Because here's 2 lines there, there's 2 lines there, that's 4 lines, so that's that. If we have something like this, we have 2 lines and then a third line. So that means it's negative. It's an odd. This is even. This is odd. Again, those are more concepts you have to define to the kids. What's odd, what's even. Let's look at the properties. Remember what the properties were? We had 6 properties. Remember what the closure property was? Closure refers to the concept that if I let's say I was dealing with natural numbers. Natural numbers are 1 to infinity. If I take 2 numbers that are natural numbers, let's say 1 times 3, and I multiply them together, is that answer inside the kingdom of natural numbers? Yes. So I would put that. The multiplication operation is closed under integers. What that means is if I take a negative number times a positive number, that equals a negative number, not a decimal, So, but it's -6 is an integer. The next one we talk about, the commutative property. Commutative property of multiplication. What this one says is A times B is the same thing as B times A, which that's how we proved it to him earlier. The associative property. The associative property says how we group them together. We have three numbers multiplied together, A, B, C. But we can't do more than two numbers. So if we had 1 times 2 times 3, those are the same thing. But it doesn't mean anything if I just give two, because you'll start at 1 and multiply that way. So that's where the associative property is. I use the parentheses. The parentheses tell me what I have to do first. I have to do it by the order of operations. I got to do what's at the parentheses first. So 1 times 2 is 2. Hey, good morning. How you doing? Fabulous. I'm getting ready to go to a conference. I'm presenting at a conference tomorrow, so I'm leaving this afternoon.
Oh,
Thank you. It's in Vegas, so
it's great.
Las Vegas.
You're so lucky.
I get to go have all the good food.
Oh my God. That's good.
So how's life with you
Good. I'm gonna take a walk back to
right now?
at 19. Yeah. Oh yeah. I need it.
Good. You'll ace it. So 2 times 3 is 6. We do the same thing here. Do the parentheses. 2 times 3 is 6. 6 times 1 is 6. And that's how we show them, so we can group them any way we want to. The next property is the identity or distributive property. Yeah, so we distribute whatever's in the front. And again, kids distribute is going to be a big word for them. So it's the same as at lunchtime. What happens? These are the students. This is the lunch lady. The lunch lady gives lunch to all the students at lunchtime. So that's what distributing means. So we had 3, 2 plus 3. What this one says is we do the first one. 3 times 2, 3 times 3. Now, it doesn't matter the order you do it in as long as you follow the rules of math. The left side says I could do inside the parentheses. I'm supposed to do inside the parentheses first. 2 plus 3 is 5. And then one of the examples we did earlier was 3 times 5. That equals 15. 3 times 2 is 6. 3 times 3 is 9. And then 9 plus 6 is 15. And you show them that because it's whatever method that they like the best. The fifth property is the identity. These are all of multiplication. The identity property is what do I multiply to a number to let it keep its identity? So what do I multiply to A so it stays A? Mm-hmm. 1. So the multiplication, it's 1. We learned earlier in addition, the identity property of addition is 0. A plus 0 is A. Now in multiplication, anytime you multiply by 1, it's itself. So 3 times 1 is 3. And then the 6th one is the nullity or the 0 property. That says anything times 0 is 0. Example. So a combination of all those, it would be 3 times 0 is 0. This property will be important when we start getting with division. Because we said we know that 3 times 1 equals 3. What if we divide both sides by 3? Anything the same on top and bottom, you can cancel. How many times does 3 go into 3? Once. So that's, you can introduce division that way. We have a few theorems that are pretty important. -1 times A is the same thing as negative A. Why is that important? Because each of these can be written like that. And we could group them up, so that's -1, -1, -1, a 2, and a 3. So now that there are 3 negatives. Is it positive or negative if you have 3? It's negative. So now we go 1 times 2 is 2, times 3 is 6. So we could distribute it, expand it that way to show that that's what's going to happen. Theorem 5-9. If I'm multiplying 2 numbers together and only one of them is negative, I could take that negative out in front. That's positive. So there's 1 negative. I have 2 times 3, which equals -6. We know the distributive property. The distributive property, no, it looks like this. What about if we had a subtraction in there? This is where my method to teach students and kids, even my algebra class, treat the numbers and the signs separately. In other words, if I had -2 times 3, the first thing you do, this one's a negative, this one's a positive. Negative times positive is a what? It's a negative. So the sign's going to be negative. Don't worry about the signs anymore. Now all we do is worry about the numbers. If you do it that way, the chance of mistakes drops to next to 0. The same thing here is And this number here is positive, this one here is positive. So positive times positive is positive. Positive times negative is negative, so just AB. So it doesn't matter where the coefficient is. So positive times positive is positive. A times A. Negative times positive is negative. These two are the same thing because of commutativity. I can move A and big A and little a. So now they're the same because of commutativity. That's right. The more you stress the rules, the easier math will. And it's going to be a hard thing because kids hate to follow rules. So let's look at numbers. 2, 5 minus 3. So we have positive times positive is positive, 2 times 5. Positive times negative is negative, 2 times 3. 2 times 5 is 10, minus 2 times. So it's 10 minus 6, we get 4. And then the kids always have them checked. So it can't, any other way we could do it. Yes, we could do it inside the parentheses. 5 minus 3 is 2. 2 times 2 is 4. The same answer, so it works. Example 13a. Negative 3x minus 2. So, like we just said, this is the signs first. So negative times positive is a negative. 3 times x, 3x. Negative times negative is a positive. 3 times 2 is 6. You'll stress the concept of like terms. Okay, in order to do like terms, you have to define what is a term. So what is a term? I mean, you see all these concepts that you have to do here. How would you define a term? If a kid asks you, what is a term? You said, I have to combine like terms. What's a term? Like for this example, we have 2 terms. It's anything separated by a plus, minus, or equals. It's not always as simple as it seems. On the left side, how many terms do we have? On this side? 1. These are inside parentheses. Whatever's inside parentheses is one number. And they're multiplied. So that's the same as having a 3x. So it's only one term. But here, we have 2 terms. Because there's a plus sign separating them into 2 separate equations. See, that's where it gets complex, is because it has to be separated by a plus, minus, or equals. So this entire equation, we have three terms. We have one on the left side of the equals and two to the right side. B, we have A plus B, A minus B. This is definitely not in the lower grades. Because they first have to be able to multiply something like this. They said basically you said we have two parentheses. Whatever's inside the first parenthesis, we multiply it inside the second. And we do a couple of those examples. Here we have two parentheses. So everything in the first parenthesis has to get multiplied in the second. Okay, there's one or two ways you can do it. The way we learn in college is the FOIL method. But what what really occurs here is a distributivity. Like we did up here. Everything here multiplies to that one. So we get A times A plus B. Remember, the sign in front of the parentheses is a plus. So positive times negative is negative. A plus B times B. Now, because before you introduce this to them, you have to introduce the concept of exponents. What is A times A? A squared. They're both positive. A times B is AB. That does it for the first one. The parentheses are gone. Now, negative times positive is negative. B times A is AB. Negative times positive is negative. B times B is B squared. So whenever this is also stress the fact, whenever you get rid of parentheses, always combine like terms next. So do we have anything that looks the same here? Yeah. They're both ABs. One's positive, one's negative. That means they cancel each other. So we have that has a name. The subtraction is the name of it is difference. It's the difference of two squares. Because they're both squared terms. So you do another example of this, then you start showing them, look at the relationship. We have the same numbers inside there. What's the difference between these two parentheses? Yeah, they're both the same, A, B, B. There's only if the signs are different, the numbers are the same, we could just jump straight here. Take whatever the first number is, square it, minus whatever the second number is, and square it. That's the difference of two squares. Because then we'll give them this example. X plus 2, X minus 2. So you know, the first thing you do, you show them how This whole parenthesis goes, and there's a minus sign. And we distribute. And then we show them a shortcut. So the rule said, take whatever's here and square it. Minus, take whatever's here and square it. And show them a shortcut. Which is what our example 14 is all about. 4 minus b, or 4 plus b, times 4 minus b. Use a shortcut. First thing, you ask the students, is this a difference of two squares? Do they have the same letters and numbers? A, B, 4B, 4B. Different signs? Yes. So now we use a shortcut. So we have 4 squared minus b squared. So it's 16 minus b squared. The next one, negative 4 plus b, negative 4 minus b. Exactly. Yes, very good. So it's negative 4 squared minus b squared. And so many students are going to not give the answer because they think it's wrong because it's the same one you just had. Or if you have an example that equals 0, students said, no, I just did all that work, can't be 0. I did something wrong. So, all right, the third one was x plus 3 squared minus x minus 3 squared. You're off. This one's kind of going back. This is not fair. This is kind of going backwards. Because isn't this the difference of two squares? So where did that come from? So if I gave you a squared minus b squared, where would that come from? Yeah, so this is a and this is b. So we have x plus 3 plus x minus 3, x plus 3 minus x minus 3. So in the first bracket, we can drop the first parenthesis, x plus 3, and we can drop the second one, x minus 3. Why can't we drop the first parenthesis? Why can we? Because there's nothing in front of it. So we could drop the first parenthesis. But the second one here has a negative, which we have to distribute. We got rid of parentheses, so we do what? Combine like terms. So in the first one, we have the 3 minus 3 cancel, so we have 2x. In the second one, the x's cancel, so we have 3 plus 3, which is 6. Which is 12x. So what grade do you think this will be introduced in? Way before. 5th, 6th, 7th grade. Well, see, here's the thing about middle school. What you learn in middle school, you repeat in high school. What is middle school really good for? It's social interaction. You're going through puberty, all this sort of stuff. So that's why everything you learn in middle school, you're going to redo it in the first 2 years of high school. Because your mind's not in the classroom anymore in those years of development. So, but yes, I mean, most kids will start remembering what this is in high school because, again, in middle school, they're thinking of something else. All right, now, because remember we said earlier that the distributive, you have to be able, equal sign means you have to go both directions. If I give you this, we got this. So if I give you this, you should be able to give me this. What makes up 16? Which is 4 squared. So if you could write this equation like this, we know it's the difference of 2 squares. If it's a difference of 2 squares, it comes from 4 minus b, 4 plus b, which is kind of what this one says. Because, and we could take that one away. But because that's a square, inside here could be a plus or a minus. So let's look at factoring now. Example 15. X squared minus 9. So what's that going to come from?
From x plus 3 and x minus 3.
Very good. Because we can rewrite this one as that. This one. Is it a difference of two squares? Because here we have the first one, it's squared, minus second one. So it's this first one, x plus y plus z, x plus y minus z.
I have the outside the parentheses.
Well, yeah, or you could do it like this, but you'll see that those parentheses aren't really needed because there's no coefficient. Yeah, so since those aren't really needed, we have x plus y plus z, x plus y minus z. How about negative 3x plus 5xy? Since there aren't any exponents, we know it's not difference of two squares. So we look at, do they have anything in common? Yeah, they have an x in common. Take it out. Whatever's left goes inside here. So to figure out what goes inside the parentheses, whatever I factored out, divide both of these by what you factored out. Yeah, so we have negative 3 plus 5y. Yeah. And that one.
Would it be x minus 2?
What did you factor out? What do they both have in common?
When you try to simplify with the 3, I cancel out the 3 with the.
Well, yeah, but you can't cancel it because you have to be able to go both directions. There's this one here. If I multiply this, I get that. If I multiply that, I get that. So what do they both have in common? They both have a 3 in common. So I take out the 3. Now I divide by 3 to see what I have left. So there's the answer. Which now brings us to division. These are all the ways division can be represented. The only thing about this is that b cannot equal 0. The second number, the bottom number, you cannot, because 0 cannot divide by 0. It's undefined. The formal definition of division is this. A divided by B equals some number, some unique number, C. Such that A equals C times B. Six divided by two equals 3, right? So it's the same thing as saying 6 is equal to 3 times 2. Whatever is here on the bottom, if I multiply it over there, I get the top number. And same rule goes with division as it does multiplication with signs. If you have an odd number of signs, the answer is negative. If it's even number, it's positive. So 12 divided by -4 is what? Yeah. So there's only one negative sign. 12 divided by 4 is 3. Same thing if we had -12 divided by 4. It equals -3. -12 divided by -4. -12 divided by 5. No solution. Why? What numbers are we dealing with in this set? Integers. So there is no unique number, integer, that multiplies by 5. So there is no unique integer. A times B divided by B. A times B divided by A. So this one, B cannot equal 0 and A cannot equal, you can't divide. So, and there you have it. That's that whole section. And the last part is what I have to do with greater than, less than. We've talked about that already. Okay, everybody. On Wednesday, I will be lecturing from my hotel in Vegas. If you want to, I mean, if you, I'll be online, but if you want to, you could do it, or I'll send you the video. Since I had nothing else to do over there after I finish eating and stuff, I'll process everything as fast as I can. All right, have a great week.